have no classes, and about the grades for this course, you would have time for studying the projects, and I will ask you some questions from the code. I will give you the code which we had done on the exercises, and you will study it, and then I will ask you, for example, what means this line of the code, and if you answer it, you will get the grade for this course, and if not, you have to more study for understanding the program. Okay?
Okay. Is it possible that you send us the codes and the data sheets, all the stuff, so that we can?
Yes, I will send you the codes and the data sheets. It will appear on the class on the course download folders, and I will give you all the materials there. I will name the folder, for example, Erasmus. Okay?
Okay. Thank you.
Okay, you're welcome. So now we will start to program an LCD display connected to the microcontroller. Okay, about the, I will share my screen. Okay, I have connected an LCD display to the microcontroller, and do you see my camera?
Yes.
Yes. Okay, it's this type of an LCD character display, and I will explain how it's connected to the microcontroller and how is the software set up for the function. Okay, first about the LCD module. This type of module uses driver type KS0066, and it's a common driver for most displays. They're fabricated for the microcontroller and for the commercial electronics. This KS0066. Okay, about this type of display. This is the data sheet, and okay, about the numbering system. The first letter is manufacturer. The second letter is module type. It's C for the character display that we have, or it's G for graphic display. Graphic display means some black and white display, which has not the pixels for some grayscale value, but you can only turn the pixel on or off. This is graphic type of these simple displays. In character display, you could write, for example, some sentence or word or some numbers or characters. And in graphic type of display, you could display, for example, a sinus curve or some simple picture or so. If you want to write, if you want to display a text on a graphic display, you have to include the libraries for font. They are transforming the text to the certain font, for example, Times New Roman or Arial. And in the font, you will choose the size of the letters, for example, 12 pixels or so, the height of the text. And then the font library will translate it to, for example, the word. It will translate the word to the picture, and then it will display it on the graphic display. But we are not using graphic display. The next number, it's in our case 1602. It means 16 columns and 2 rows on the display. Or if it's graphic type of display, it means the pixel number in horizontal and vertical axis. Okay, this version, and then it's LCD color. It's for example, it's super twisted nematics. It's the structure inside the LCD panel. It's the structure of the liquid crystal, the STM. Gray means that the reflection layer, it's gray, or the backlight. It's the LCD color means that how the display will appear to you. Okay, it could be, for example, OLED display, it's organic LED, or some other types. Okay, then it's LCD type. It's even positive or negative. Positive means that the when it displays, for example, the character 1. Positive means that it's a dark 1 on the light background. It's dark letter on a light background. Negative means that it's a light letter on a dark background. This means the positive or negative. What is the type of the LCD? Then it's reflective. Reflective means that this type of display has no backlight, and without backlight could be only positive displays because the surrounding light from the display let you read the display. So if you have a reflective display, you could read it only by some daylight or external light or something. Then it's the next type is transmissive. Transmissive means that backside of the LCD has no reflector. It has transmissive layer, which let the backlight light through the LCD panel. This is the transmissive display. The combination of the both displays is transflective display. The transflective displays, you are using some type of mirror that let some light going through it. I don't know the exact term in English, but some type of mirrors, when you light with a torch, for example, on the back side of the mirror, you will see the torch through the mirror. I don't know how it's translated, half reflective mirror or so. It lets some light through it. It's used, for example, in physics, this type of mirror. And these transflective displays are, you could read it in the daylight or and some external light without using the backlight. But it has possibility to light the backlight and, for example, in the dark, and increase the contrast of the reading. So transflective is the combination of the reflective and transmissive display. For example, your mobile phone or your monitor are using only transmissive type of LCD. If you have LCD type, if you have no OLED, they are using only the transmissive type. In the transmissive displays, you need the backlight to see the information. In the reflective, there is no possibility to add the backlight in the reflective type. In transflective, you could read it in the daylight, and then you can turn on the backlight, and it's the combination of the both. Then it's backlight type, it's even LED, or there is some no backlight displays, or electroluminescent display, or CCFL backlight. CCFL, it's like it's a very tiny something like a neon tube, some gas tube. It's very tiny. It has diameter only, for example, 3 millimeters, and it's on the one side or two sides of the display. It uses higher voltages to drive the tubes, the gas tubes. This is the CCFL type. Okay, then it's a CGRAM font for the character displays. In our case, it's mostly the English European font. Then it's a view angle and operating temperature. View angle means that, do you see my camera?
Yes. Yes.
View angle means that if the display is constructed that you will read it by this way, the text will be read it by this way, or it's constructed that it has the panel upside down. It depends on the on this connector, on which side do you want the connector. For example, this type of display has connector on the top, but if I would want to construct an electronic which has the connector here, I have to choose the other type of the display, which will read upside down, and then I will turn the display upside down. This is the difference between top and bottom. If you use another type, you will construct the electronics which the text upside down. So you have to read the datasheet carefully or try it, the top or bottom. Then it's normal temperature, white temperature, ultra white temperature. The LCD display have the common disadvantage that they are very sensitive to the temperature. The normal temperature display is possible to use only indoors. For example, by the temperature, I don't know, 20 or 22 degrees or so Celsius. If you want to operate the display outdoors by temperatures, here in Slovakia, I don't know, from minus 20 degrees Celsius up to inside of the car in the summer, which could reach, for example, 60 degrees Celsius plus, you have to use the ultra-wide temperature, because the normal temperature display will, in the temperatures below zero, it will not display properly the characters. It could have problems like low contrast, very slow reactions of the LCD panel, and so. So this is the operating temperature. And then some special code if it's 3-volt logic or 5-volt logic or so. Okay, the controller is the common controller KS0066, which is used for the most types. About this type of controller, this is the interface to the microcontroller. And when you want to use vacuum fluorescent display or OLED display, they will have mostly the same interface for the microcontroller. But they would be more expensive. But they would have a wider temperature range. They would have a large view angle, and so. They have more advantages, OLED and vacuum fluorescent like LCD, but LCD is very cheap. This type of display costs, for example, €6. Okay, these are the electrical characteristics. This is the view angle. LCD have a common disadvantage of very low view angle. like 40 or 50 degrees. Okay, the interface connections. The first pin is ground, the second is supply voltage, 5 volt in our case. The third pin is a variable voltage from the resistor, dividing, and it's a contrast voltage for the LCD. So you have to turn there a potentiometer, which is consists of some changing resistance, where you have divided the 5 and 0 volts to some voltage. Mostly it's around 4 volts, but you have to set up this contrast voltage. Then are 3 control pins. It's reset, read write, or enable and enable. These you have to turn to the connect to the microcontroller. Without them, there will nothing work. Then there are 8 data bits. In our case, we are using only last 4. So this bit 0 to 3 we are not using. This driver allows us to drive the display only using these 4 bits. The last 2 pins are connection for the backlight. This is the connection of the contrast voltage. Typically, it's 4 volt. Okay. Where is the... Okay, the supply current of the LCD, it's 1.2 milliampere. It's 1.2 milliampere. But when you see the power consumption of the backlight, it has consumption of 100 milliampere. If you buy a larger display, it could climb up to 200, 300 milliamperes. It's the backlight current. So the backlight consumption, power consumption, is much higher than the consumption of the display itself. Okay. This is the shape of the pixels. And this is the description of the communication. We will see in the code that it's very simple to use the data sheet and the driver. And this you will only tell the display that you want to display, for example, this character A. These are the lower 4 bits, and these are the upper 4 bits, and you will address, for example, the A. You will see that it's very simple. This is about timing. This type of display, you will see this chart that this display has, for example, wait 4 milliseconds, wait 100 microseconds, and so you cannot use it in the interrupt because it's the communication with this type of display is very slow. Okay, we are going to the code. This is the project, and I have added this driver for the display. Okay. This uses some include files, and this LCD KS0066.c, it's not important for us because it's containing some functions for the communication. We are not changing it. For us, it's very important, this .h file, where you are changing the most things. The first thing you have to set up is the CPU clock frequency. For the Arduino, it's 16 megahertz. So it's first important thing to change. For example, when you are using microcontroller with 8 megahertz, you will write there 8 million. In our case, for the Arduino Uno, it's 16 megahertz. Okay. Then it's the definition of the size of the display. This character display has 2 lines and 16 characters per line. If you buy a larger display, you have to change this. For example, when you have 4 lines or 20 characters per line, you have to change it because when you connect the larger display to the microcontroller and it will contain this only 2 and 16, you cannot use the whole area of the characters. So you have to set up it properly according to the display. Okay, the next is the port and pin connected to the microcontroller. In our case, do you see my camera?
Yes.
Okay. In our case, this it's the reset pin of the display. It's connected to my Arduino to digital 2. It's some port D, I don't know. It's port D2. Port D2. It's the reset pin. Then it's the read-write pin, the brown wire. It's connected to the 3, and it's PD3, I think. Yes, it's PD3. The LCD port means port D. Port D. You can see it here. It's defined as a port D. It's defined here. Okay?
Okay.
Okay. The enable is port D4. The data pin, the data 0, it's connected, it's for data wire connection, and it uses only the upper 4 data wires of D4, D4, D5, D6, and D7. It's connected.
Profesor?
Áno?
Ja tu nemám robiť čo na tejto hodine, ale videl som, že teda ju máte a chcel by som sa iba spýtať. Ja som pán Adam Stančík.
Áno.
A vlastne ohľadne toho, že ja som vám už posielal ten program, vlastne tam bolo čítanie S-basu A ste mi neodpísali a vlastne by som sa chcel teda opýtať, že kedy sa to bude obhajovať alebo ako sa zakončuje semester, pretože nemáme ani so spolužiakmi tieto informácie.
Počkajte na skončenie hodiny, dobre?
Dobre, samozrejme. A kedy končí, aby som sa potom pripojil?
10:30.
Ďakujem pekne.
Tak. Okay, it's these last four wires, D4, D5, D6, and D7 are connected to these Arduino pins. It's port D5, port D6, port D7, and it's the last one. It's connected to the port B, because port D has only 8 wires, and port B is the last data pin. It's port B0. Okay. Fine. So you have to define where is the display connected to. Then there is nothing to change in the driver, because it's containing the function for the communication. So you are not changing the instructions. Okay. So you have to set up the clock frequency and this wire connection to the microcontroller. Okay. In the main, what you have to do in the main, you have to set up the frequency, some includes for STD or STD-lib, AVR-IO, AVR interrupt, program space, and our driver, LCD KS0066. Then this is the definition of some custom character. We are not using it in our case. And how is the display programmed? First, you have to use the function LCD init to turn it on, LCD display on. Then you have to clear screen, and then this go to epsilon means the row and the column of the beginning of the text. Then you are using LCD put screen for the text, LCD put string for putting the text to the display. You could use, give there the text directly, or you can use some string and put there the string. Okay. This is shown on our microcontroller. This is the word example. You could change it, for example, for the word, for example, clock. Okay. Do you see it?
Yes.
Yes, okay, it has changed.
Yes.
Okay, so we will use the code from the previous lesson to display a clock on the information about the time on the display. So first we have to set up the timer 1 for the 1 second interrupt. Okay. This enables interrupt by T1 overflow. This is setting up the clock division for the timer. This is the timer 1 setup. Okay. Next is the serial channel. This was interrupt by right on RX. And the second one, RX enable receiver enable, enables RX receiver zero. This is the baud rate settings. Baud rate settings for 16 megahertz. Clock and 1600 baud rate. Okay, this is the setting for the serial interface. The next, we have to copy from the previous lesson the code for the clock. This is all from the previous lesson. Okay. and this is the hours. Hour. Okay.
Yes.
We are not using this. So the code for the clock, it's the interrupt occurs every 1 second. We are incrementing the seconds. If they are more or equal 60, we are doing the seconds to 0, incrementing the minutes. If the minutes are more or equal to 60, we put it to 0, increment the hours. If the hour is more than 24, we are putting the 0 to the hour value. This is the simple code for the clock. Okay. How to display the clock on the LCD? Very simple. We are going to the 0, 0 position. First, we have to put the 0 to the clock. So it will start on the midnight, for example. Okay. When we want to display the hours and the minutes and seconds, we are using sprintf function. Zero to the and then we are using the variables for the hour, minutes, and seconds. Okay. We are putting to the display. What does it mean? This %02 means that if there, for example, hour is less than 10, then it will appear like 01, 02, 03, 09, and 10. It will have every time the same amount of digits. Okay?
Okay.
Okay, we are trying to okay, it's counting. So the clock is counting, okay? Do you see it?
Yes.
Okay. The next, on the last lesson, we have used the GPS for receiving the time signal. Okay. Okay, string index, AMC, delimiter string, delimiter count, time zone. This is understandable. Okay, if the serial interface receives an byte, you have to pick it up first because the UDR register already receives the next byte. And if you will not pick up first the received byte, you will you could have a data overrun error on the microcontroller. So first you have to pick it up, the character. If the received byte is $, okay, that is the beginning of all NMEA sentences like G and RMC and so. We are, if this byte is $, it's we are putting the string index to the 0 because the sentence is beginning, and the count of delimiter, which is the separator of the information. For example, this is this sign is used for the separation of the information. If the string index is less than 20, because we have only 20 characters in the RAM for receiving the string, we are filling the received string with the received sentence. If the received byte is comma, this this sign, the delimiter string, which is the array or the string which contains the positions of the first, second, third, fourth delimiter. It's filled with string index in this place, and the delimiter count increments. So the delimiter string looks like this. This is the 6. The first thing in the delimiter string is 6. Why? This $sign is 0. Then it's G. It has index 1. N has index 2. R index 3. M index 4. C index 5. And this sign, we are searching for it. It has the position 6. Okay. This is the position of the first comma. Okay. Do you understand it?
Yes, okay.
Yes.
This one has the index 7. This has index 8, 9, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The next comma is 16. Okay? In this sentence. Okay? This is the position of the next comma. Okay?
Okay.
Then the A has position 17, and directly after A, it's the position 18. Okay, and directly after its next comma. Then it's latitude information, 49 degrees in the north. And after it, this is 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, and this comma is 29. Okay? This describes the position of every comma. Okay, do you understand the field, the array, or the string of the separation signs? Could we proceed?
Yes, yes, yes.
Okay. If the string index is more than 5, so this is up to the first comma, because it's 6, 7, and so, and the string, the third, fourth, and fifth characters are R, M, C. Here in the sentence, we are checking these letters if they are R, M, C. Why? Because from the GPS, this is the information online from the GPS. Now, stop it. And this RMC sentence, this GPS receiver gives you more information than the RMC sentence. It gives you the satellites in view and the every next information about motion and so. So we have to separate only this sentence, the RMC, which gives you the time, latitude, longitude, speed, azimuth of the speed, and the date. And this is the checksum. This is the basic information from the GPS, the RMC sentence. We want to separate only the RMC sentence. Okay. So if the string is containing R, M, and C on the third, fourth, and fifth position, we put the RMC to 1, and Otherwise, we put the RMC to the 0. Sorry. So when the RMC sentence is received, the RMC is 1. Otherwise, the RMC is 0. Do you understand the RMC recognition? R, M, and C. Do you understand it?
Yes.
Okay. Next, if the RMC sentence is received and the length of the string is more than 18, this is the information up to here, and the received string 1 plus delimiter string 1. The delimiter string contains the information about the commas. This is the delimiter string 0 is the information of the position of the first comma. Delimiter string 1 is the information of this position. Okay, this is 16 in this case. But we are using 1 plus. So it's the next position after the second comma. If this string is an A, an uppercase A, then the GPS information is valid. It contains actual data of latitude, longitude, speed, time, date, and everything. If there is A. If there is not A, the GPS receiver is not receiving the information from the satellites. So we could not rely on the information if there is not an A. Okay? If sentence is RMC, if longer than and if next character after second comma is an A. So if it's longer than 18 characters, if the next character after second comma is A, and if the sentence is RMC, we will proceed the sentence. Do you understand the condition?
Yes.
Okay. So we are putting to the seconds the received string 6 plus delimiter string 0. What means delimiter string 0? Delimiter string 0 means that this first comma. Seconds. Position from first plus 6. This gives you directly this received character. Okay, because from the first comma is the 1, 2, 3, 4, 5, 6. These are the seconds. Okay.
Okay.
But we have received the information as a text with an ASCII coding. So, and in the ASCII table, the numbers begin with 0, are going to, then is 1, 2, 3, 4, 5, 6, 7, 8, 9. From 0 to 9. They are directly one by another. So we have to remove from this information when in ASCII table the 0 is, I don't know, for example, 48. When the 0 is 48, we remove this from the received string. We subtract this from the received string. And for example, when here it's the 4, this character when it's 4, the 4 has, for example, address of 52 in the ASCII table, and the 0 has 48. So when we subtract it, we get the 4. So we get the number from the ASCII table. Because we want the number in this variable from 0 to 9. Do you understand it?
Yes.
Yes.
Okay. When you look to the ASCII table, okay, the 0, it's 48, the 1, it's 49, and so on. When we receive the 4, it has address 52, but when we subtract 48, we get the 4. Okay?
Okay, yes.
I could write there the position of the 0. For example, in this case of ASCII table 48, it will do the same, but I have not to remember the position of the 0, so I'll put only the character 0, not the 0. Okay. Next row. We add to the seconds from first comma plus 5, from the first comma plus 1, 2, 3, 4, 5. In this case, it's 0. Subtract again 0 address. The number. Okay. We multiply it by 10 because it means the 10 the information about the 10 of the seconds. Okay.
Okay.
Okay. We will do the same for minutes. And the same for hours. Okay. This hour plus time zone means that we are using the time zone GMT plus 1, like in the same it's as in France, Germany, Czech Republic, Slovakia. It's a Central European time, the time zone 1. We have to divide it modulo by 24 because when we get the information that there is 23 hours GMT, we add 1 as our time zone. And in a midnight, the clock will display 24 because 23 plus 1 is 24. And if the GMT will be 0, it will add 1, so it will display from 10 to 24 to 1. It's probably not the worst problem in GMT plus 1, but when we were in Finland or Russia, there is the time zone GMT plus 2, it's East European time, or in Russia it's GMT plus 3, and the clock will display without this dividing modulo 24. For example, in Finland, it will display 23 in the 11 o'clock at the evening, 24 at the midnight, 25 at 1 o'clock in the morning, and then it will jump directly to the 2. In Russia, in Moscow time, it will display 23 at 11 p.m., 24 at the midnight, 25 at 1 o'clock, and 26 at 2 o'clock. Okay, so you have to divide it modulo by 24 to get the correct displayed information. Okay.
Okay.
Okay. Program it. Okay. Now I will connect the GPS receiver to the clock. Do you see it?
I'm not sure.
Is the information correct?
Yes, it is.
Okay. Fine. So we have done this code. If you will enlarge this received information, for example, to 80 bytes, and receive the whole sentence, not only these 20 characters, but the whole sentence, you could display also the day, month, and year information. For example, okay, we added these variables, and we could proceed with the next enlarging this to the date. Day, month, and year. And when we look to the information what is received from the GPS, how we will process it. Okay, this is the index of the comma 0, 1, 2, 3, 4, 5, 6, 7, 8. So the date is after 8, comma number 8. Okay. Okay, the day information is the first information. So the so the date is here. It's the 10th. These are the 10th of the day, and these are the units of the day. So this is okay. This is okay. So the comment will okay. The month is the same, and the year it's 21. But we don't have the year 21, but 2021. Okay, so we have to add the 2000 to the year information. Okay. Okay, so we have parsed the string to get the hour, minute, second, day, month, and year information. So we will display this information on the LCD. As the day, month, and year. We will separate it by dot, not by comma or double dot. And this is the 1, 2, 3, 4, 5, 6, 7, 8 position on the display, so it will not overwrite the information of the date. Okay, and
Počúvaj, no, povedz mi to ešte raz. A čo to je? Pi. To je pištolka, on je povedať pištolka. Pi.
or we could put it on the second line. Okay, Do you see the display?
Yes.
Okay, we will connect it to the GPS. Okay. Is the information correct?
I don't see everything.
I think so.
What I think. We have 2021, but there's like one more character at the end.
Okay. The next thing we have to do is only display the information if it's updated. So we have to define the next variable, LCD update. And if the information is updated, we put the LCD update to the 1. And we are displaying only by update. If the information is updated, we display it. We clear screen. And we put the LCD update to the 0, so it will be not displayed every time, only by updating. Okay, the clock is not updated, so we connect it to the GPS. Okay. What else? The update not here, but in the seconds update, not by receiving the okay. Okay, Now we want to update the clock. Okay, it's updated, but it's not displaying the second row. Okay.
Áno, no dobre. Dobre, držte sa. Mal šťastie, Dovi, že v pondelok je objednaná. Majú v nemocnici teraz problém. 100 ľudí tam teraz čaká. Úplne pučky sú tam totálne. Tvoj fotel už je vybavený. Ale že niečo im tam...
Okay.
No, ľudí to sú všetko 50-60 roční, vôbec takí, čo nemajú mať ani teru, vieš?
Okay. This is the.
Že prišiel termín, registroval si to?
Okay, I have problems with the addressing the second line, but this is how it's synchronized. The synchronization works, but the displaying the second line doesn't work now. So I will get you the code. Okay, thank you for attention on this lesson, and see you next time. Bye.
Bye, thank you. See you next time.